Greetings and welcome to In-Depth. I'm Dike Rostant. We are here at the Caribbean Industrial Research Institute seeing some of the services they provide. We are starting with the Occupational Hygiene Services Department. We are speaking with team leader Tisha John. Thank you for making the time, Ms. John. Very happy to have this conversation. What are some of the services that the department provides?
Well, we go into a work environment and we can measure any chemical or physical hazard that an employee might be exposed to, compare it to standards, and then provide recommendations to improve that work environment.
So that also, I like the fact that you also talk about suggesting improvements as opposed to just monitoring and seeing what is there. But what are some of those variables, factors that you would measure in someone's working environment?
Okay, so we have chemicals that somebody might be exposed to, for example, benzene, total volatile organic compounds, toluene, various things that a person might be exposed to, for example, in the oil and gas industry, in an office environment. Then we have, I know a lot of persons are concerned about dust now, so we can measure it for particulate matter, which is dust in a work environment. We also have lighting. Sometimes if you don't have proper illumination in your work environment, you might get headaches, for example. And obviously one that most persons are concerned about is noise levels. Matthew will soon talk about noise in the next session, about how noise can affect persons in the workplace, for example. We also do environmental type monitoring where it's area monitoring, so it has to be able to be set up in the work environment. So it's robust and it can work both for personal and area monitoring.
How do you arrive at the work site? Is it that management asks you to come? Is it that the union may have an issue? Is it that someone can get referred or suggest that you get there? How do you approach an area to say, okay, well, we're going to do this monitoring exercise?
Well, usually management contacts us because they either have to make regulatory commitments or there's a complaint from an employee. And in most cases, we are in a reactive society. So most cases, management will call us in due to a problem that they have in the workplace. We come in, we test, we make recommendations to improve that work environment.
Okay. So you spoke about chemicals, I think you spoke about sound a little bit, and we want to go through some of the equipment. So you'll give us a description, and then I think we'll actually get some hands-on, literally in some cases,
yes, of course,
experience what some of the equipment that you use guys.
Sure. So I would like to start with the noise monitor. So this monitor is it's very light. So in an industrial environment where somebody have a lot of tasks to do for the day, we actually just set it up on the person like this, close to the air as possible on their lapel, and we can determine what their noise exposure is for that work shift. And usually this is done in the oil and gas industry, most importantly because we have persons exposed to high noise levels because of machinery, for example. So we have the noise meter. We also have a gas monitor here that we measure for various gases. Usually if you have a scent in your work environment, for example, you'd want to know what is that, and we can determine that here at CARIRI. We also want to make sure that those gas levels are not too high and it's not affecting your health. So we use this multi-gas monitor in order to be able to do that. We also have this very versatile pump here that we can set up on someone, and it can test for various gases and dust as well. This is important in the construction industry, for example, where persons may be exposed to silica dust, and we want to make sure that does not cause any serious health complications, for example, cancer of the lungs. So everything you may be exposed to in your work environment, we can test for it and make sure it's not above a limit to cause health concerns.
And while you're saying this, I'm also thinking that there would be some level of monitoring that would be set up, well, hopefully on site on a consistent basis. So is it a matter of also going and helping to recalibrate, make sure that instruments are measuring the way that they're supposed to? Is that something that your department would be able to help individuals or in the workplace with?
Yes, we do our calibrations. We also have to send our equipment for manufacturer calibration, and that is very important in industrial hygiene monitoring because it's very, we must meet regulatory standards. And sometimes CARIRI is called in for court cases because it's a litigation matter. So we must be able to demonstrate that our instruments are calibrated properly, and we have trained staff that is doing the calibrations as well. Usually it's not very often that we have companies that have their own equipment that they want us to calibrate. Usually they want independent independent results basically. So we are calling to come in with our calibrated instruments.
And I keep on thinking that there's so much about CARIRI and the services that are offered that we don't necessarily know about. If there's one thing that you think is the best kept secret about the department that you're team leader for, what would that be?
It would be that CARIRI can test your work environment, and particularly if you have a complaint, we can measure inside your environment, determine what is the source of the problem, and then provide you with recommendations for improvement. So here we have a heat stress monitor. If, for example, you are in the construction industry and you're working outside in the sun all day, we can set up this meter in your work environment and tell you how long you can work in that environment based on the wind level, your clothing, what is the wind direction, all these different things, and be able to give you a work rest regime. So we can tell you, okay, you need to work for 45 minutes and take a rest at 15 minutes because we don't want persons experiencing heat strain, heat stress related symptoms such as fainting, etc. So this meter is quite versatile. It can work in different environments. Once a person is exposed to heat stress, for example, in food industries is a good example.
And lastly, I think we're going to get the opportunity to have some of the equipment put on. But just before we do that, letting you know that we are going to the unit leader for the air quality management services after we take the break. His name is Matthew Yick. Stay with us. We come back after this. We are here at CARIRI, and one of the things I realized about CARIRI is that there are a lot of acronyms. So we're very happy to take you through the acronyms, what it is they mean, as well as explanation of the services that they provide. Now we're here with team lead, or unit lead rather, Matthew Yick of the Air Quality Management Services, AQMS for short, and we're going to be finding out a lot of the equipment that they use and how it is they use it to benefit us here in Trinidad and Tobago and beyond. So Mr. Yick, thank you so much for making the time. What are some of the things that the unit is responsible for?
So the AQMS unit stands for Air Quality Management Services, and we primarily do three things here, what's referred to as point source emission testing, or commonly known as stack testing, ambient air testing, and noise monitoring, which is popular around carnival time.
And stack testing or point source testing, what stacks do you test? What points do you actually look and say, okay, well, these are the things that we're monitoring?
Well, to begin with, you need to have an understanding of what a stack is. It's basically any vent or exhaust from a combustion process. And in the background here, we have a typical stack. So these are these tall structures that you see on the industrial estate. So we'd usually climb those, and up there, there are ports that we would test at. So that's sometimes 100 feet in the air, 135 feet in the air. So we'll be up there testing all day.
So you actually need to go to that point, and this is logging the equipment as well to be able to check that quality.
Correct. So all of our testing is on site, both stack and ambient. So we do mostly industries, funeral homes. We have some small manufacturing businesses as well.
So different people have different outputs. What are some of the things that you're monitoring or measuring for?
So all of our monitoring is guided by the EMA rules. There's the EMA air pollution rules for stack and ambient, as well as the noise control rules. So there, there are the rules there that stipulates what we need to test for. Some of the common things are carbon monoxide, carbon dioxide. We also have heavy metals, compounds that could really interfere with you. And also, in terms of noise, they have limits set for 3 zones. There's industrial noise limits, sensitive areas, and then general, which is like residential areas and whatnot.
So it's one thing to know what it is you're testing, what it is you're monitoring in reference to the guidelines from the EMA. It's another thing to know the equipment itself.
Correct.
So start to talk to me about some of the equipment now.
So the equipment, they're very rugged. Everything we use outdoors. So we have first of all, the ambient particulate model. It's called a TS minival sampler. So how it works, everything is basically a sample pump, and it draws in a sample. For the particulate sample meter, it's captured on a filter paper, and we bring that back to the lab in CARIRI, and we weigh it. For noise monitoring, we use pulsar cirrus noise meters, and we usually carry that out on site. If it's a facility that's going to emit a noise, or if somebody is complaining about a facility that's creating a noise, we go set up on site and we'll monitor over a stipulated period, and we'll compare those to the rules to see if they over or below the limit. Apart from that, with stack monitoring, it's a lot more robust than the ambient monitoring, a lot more physically involved. So the equipment is referred to as a manual sample train, and that could be set up in different variations, different attachments to sample for different parameters on the rules.
Is part of the training to be a member of the team, moving the equipment, getting up? Do you need to pass certain physical
oh yes, most definitely. Because of the robust nature of the job, the team tends to be a fit team. It's something that we look for in our employees. But with technology and with a good team behind you, anyone can do it.
All right, so I think you want to actually start going around and looking at some of the equipment, because it's one thing to be told about it, right? But to actually see it and see how it's used, at least from inside here, that's one of the things we're going to be doing. So we are speaking with Matthew Yick, Unit Lead at AQMS. All right, Mr. Yick, take me through this instrument, thank you.
So this is our minival tactical air sampler, tactical being named so in that it's portable. There's an internal battery, so you could use this anywhere in the field without the need for power from an extension cord. It's also weatherproof. So inside here, there's a pump. It pulls a sample of air through the top where there's a filter paper. So as it pulls the sample of air, particulate matter is impacted on that filter paper, and then we take that back to the lab and we weigh it. With this piece of equipment, we can monitor TSP, what is referred to as 2.5, PM10, and also total particulates.
So how long does the battery last? Because I could imagine sometimes you may want to get it over a course of period of time.
Correct.
Or is it that you're changing the filter paper after a certain period?
So this equipment, typically the battery could last over a 24-hour period. Most of the ambient monitoring standards ask for monitoring to be done over a 24-hour period, so equipment is kind of built within that.
And is it a matter of calling to ask, or you have agencies, or is it concerned citizens? How does one get to reach out to CARIRI to get this kind of monitoring to the area?
Once you're a facility and you have a CEC or APR that requires ambient air monitoring, you can contact CARIRI, and we will come, we'll take a look at your documents, and we'll see what you need to do, and we'll get it done for you.
You're going real good. You finally hit me with the jargon. Is CEC?
CEC, yes.
What's that, sorry?
That's a certificate of environmental clearance. That is issued to any facility that's doing some sort of industrial operation.
Okay, what's the other one?
APR, that's air pollution rules, is another certificate that goes before the CEC.
All right, thank you. So from here, what instrument are you going to look after?
So we look at our noise monitor after. This is our pulsar noise monitor. So what we have here on this tripod is a microphone inside of here, and it's connected to the pulsar meter on the ground. So this is the pulsar here. So this is taking real-time measurements of the noise level. We will set up, and we will, in real time, see what the noise levels are over the course of the FET. So we will do something called fence line monitoring. So we want to monitor the point on the fence closest to the residential area, or closest to the area that the noise might be affecting.
Does the level of concentration of individuals in an area affect the amount of noise that can be used, exploited, that can hear, in terms of less people, more noise?
No, generally not. What I would say is that on the noise control rules, there are two limits. There is the instantaneous noise, which is the single highest sound level that you don't want to cross. And then there's the continuous noise, meaning that this is the most amount of noise you can make for a continuous period. So you don't want to exceed that.
Okay. So if somebody have a problem, they call an EMA and then EMA call an CARIRI?
They could actually contact CARIRI directly. This is in the case of a client who might be doing some kind of operation on their facility, like demolition. They could call us to just make sure that they stay below the limits.
All right, great. So, air, sound, what's the next?
So we move across our weather station. So this is our Davis weather station. So in most cases where we're doing ambient and stack monitoring, we also want to monitor what the weather conditions are. This gives a little bit of, how to say it, it gives a lot more explanation to what is happening on the day, and it gives, you know, a better interpretation, or a better way to interpret the results. So our weather station.
Just direction in terms of like wind vane?
Yes, correct.
Speed?
Correct.
Rain?
Correct.
As well. Precipitation?
Yes, and you have it.
Okay.
Feel like we should hire you in CARIRI. So this is the display screen for it. So this is in real time. So and this is also logged, and the data is automatically uploaded to a cloud. So we could set this up in the field. We could stay in the office and see what the weather conditions are like. So we use a tripod setup, exactly like what you're seeing here, and we try to set it up in an area away from buildings. Usually we look at 20 feet from any kind of structure, away from like any kind of, you know, traffic, vehicles, people, and we want to set it up in an area where, you know, buildings and stuff wouldn't like overshadow it.
Okay. And you said it's real-time data?
Correct, yeah.
Okay, great.
So this setup that we have here is referred to as a standard method 5 setup. Method 5 being the method that prescribes to the test that we do. So we call it manual sample train. Just like a train, it's made up of different parts, all connected. So to just run through them very quickly, this is the sample console. It's connected to the pump, which draws the sample through this apparatus here. This is the sample probe. This is the oven box, and this is the impinger box. So this is inserted into the stack. The sample of air enters through here, goes into the probe. It impacts on this filter paper here, so it removes the particulate or traps the particulate matter. The dry gas now goes into these impingers, and these can be replaced with different reagents, depending on if you want to monitor for dioxins and furans or heavy metals. We capture these reagents and we carry them back to the lab to analyze, and everything is controlled through this right here.
No, you explaining all of this to me, Matthew, and all I studied is that somebody had to be toting this up the stack. Can you work with these things separately and then put them together?
Yes.
Or one person needs to hulk it out?
Well, I mean, while we might like to hulk it out, everything here is separated into components, and, you know, we carry them separately on the stack.
But I'm wondering though, especially on, say, like the industrial estate, would it be that they have their own monitoring equipment and then possibly they want to calibrate or something and then they call you to check it? But how is that interface going on? Because I'm thinking that there would be some level of monitoring going on.
So some facilities have what we refer to as SIMs, and that is basically continuous monitoring devices, and we do what is referred to as comparative monitoring. So they would have their monitor running, and they might want to check on it to see if it's correct, so they might call us to do an independent test.
I think it's really important that you're able to do that. And so I take it that things are built, or stacks are built with apertures or places that can be opened so that the probe can be inserted.
Correct. So most stacks would have ports. If your stack doesn't have a port, we would usually facilitate a free site visit where we'll come and we'll do some measurements and calculations and tell you exactly where that should be. And well, depending on the size of the stack, we have different probes. This is a 3-foot probe for a fairly small stack, but this could go all the way up to 20 feet.
Something else to carry up this time.
Yes, something else, something very heavy.
All right, so we want to thank you very much, Matthew. Matthew Yek, Unit Lead of AQMS Air Quality Management Services. And we continue to see what else is here in this building at CARIRI.